Hello everyone, what is up? And today we are back with another video on advanced mathematics of class 10, and we are going to continue with quadratic equations. We had completed up to question number 7 in our last videos, and today we are going to start from question number 8. So without wasting much time, let's dive into the solution. What we have here in the question is, if a square equal to 5a minus 3 and b square is equal to 5b minus 3, where a is not equal to b, then find the quadratic equation whose roots are a by b and b by a. So before we move into these roots, let's carefully analyze these two equations. So in the solution, what we are going to have is, given equations are a square is equal to 5a minus 3 and b square is equal to 5b minus 3. If we compare these two equations with x square equal to 5x minus 3, then what do we get? These equations show that a and b are the roots of the equation square equal to 5x minus 3. If you look carefully, x square equal to 5x minus 3, if I take the root of one of the roots of x as a, then what is going to be the equation? A square equal to 5a minus 3. If I take the second root of x as b, then what am I going to get? I am going to get b square is equal to 5b minus c. This means that the original equation was x square equal to 5x minus 3, and a and b were the roots of this equation. So now that we have a and b as the roots of this equation, what we can get? We can get the sum of the roots and the product of the roots. So therefore, sum of roots is going to be minus b by a. In order to get minus b by a, what I must do first is bring all the quantities towards the left hand side. X square minus 5x plus 3 equal to 0. Now it is going to be easier for us to calculate. So sum of the roots means a plus b, because a and b are the roots. So a plus b will be equal to, here minus b means minus of minus 5 and a is 1. So we are going to have a plus b equal to 5. And if I move ahead, what is going to be the product of the roots? The product of roots, as we know it, is c by a. So what am I going to get? Product of roots means a into b. So ab is going to be c by a, means 3 by 1. So ab will be equal to 3. Now that I have these two values, what I can do is, I have the roots given as a by b and b by a. So I need to find the sum of these roots and the product of these roots in order to form the equation. So now using these values, we are going to find the sum of these two roots and product of these two roots. So let's dive into that. So these are the values we had, a plus b equal to 5 and ab equal to 3. So now we need the sum of these roots. So now what we are going to do is, sum of roots is going to be a by b plus b by a. So let's take one LCM. It is going to be ab, it is going to be a square plus b square. So we know the formula of a square plus b square is a plus b whole square minus twice ab by ab. So what I have here, a plus b is 5. So it is going to be 5 square minus 2 into 3 by 3. So it is 25 minus 6 by 3. So it is 19 by 3. It is the sum of the roots, and the product of the roots is going to be, product of roots is going to be a by b into b by a. So a, b cancel, so we get 1. So we now have the sum of the roots and the product of the roots. So now you know it is very easy to find the equation. So therefore required equation will be x square minus sum of roots into x plus product of roots equal to 0. So x square will be x square, sum is 19 by 3 into x, plus product is 1 equal to 0. If I take the LCM, 3, it will be thrice x square minus 19x plus 3 equal to 0. So ultimately we get the equation as thrice x square minus 19x plus 3 equal to 0. And that is the required equation that we had to find out. This equation will have the roots as a by b and b by a respectively. Hope you understood this. Let's move on to the next question. Now we are here with question number 10. I have not done question number 9 because I believe that if you have understood question number 8, you will be easily able to do question number 9. And question number 9 is somewhat similar to the previous videos that we have solved. So if you have not seen my previous videos, I will put a link up here in the card so that you can go ahead and check the previous videos so that you can get an idea of how to solve the question number 9. So now let us move on to question number 10. So what is given in question number 10 is if 4 is a root of x square plus ax plus 8 and the roots of x square plus ax plus b equal to 0 are equal, then find the value of b. So first we will consider about this equation and this root, and then we will move on to this. Okay. So first what is given is we have, for the solution what we have is 4 is the root of this. So let alpha be the other root of x square plus ax plus 8 equal to 0. Since 4 is one of the root, we have taken alpha as the other root, so we can find the sum of the roots now. So now sum of roots will be equal to minus b by a, means minus a by 1. So sum of the roots means alpha plus 4 is equal to minus a. Let's take it as number 1. And we can have product of roots as well. So product of roots will be equal to 8 by 1. So it is going to be 8. And product means what? 4 into alpha is going to be 8. So from here we can find that alpha is equal to 8 by 4, that is 2. So alpha's value we have found. So from here we can put the value of alpha and find the value of a. So from 1 we can find that alpha plus 4 is equal to minus a. So alpha I will put 2 plus 4 equal to minus a. That means a will be equal to minus 6. So I have found the value minus 6 for a. Now let us move on to this equation x square plus ax plus b and see what we can do with this. Now the given equation is this, and it is said that the roots are equal. It's important that the roots of this equation are equal. So we know that if the roots are equal, the discriminant is going to be equal to 0. b square minus 4ac is going to be 0. So we are going to apply that hypothesis or that principle here. So for the equation x square plus ax plus b equal to 0, since the roots are equal, therefore b square minus 4ac will be equal to 0. So here b means a. Okay, let me not write b square minus 4ac, it will be confusing. So let's write discriminant will be equal to 0. Discriminant will be 0. So what is the formula of discriminant? B square minus 4 into a into c. So here b means a. So a square minus 4 into 1 into b is going to be 0. So I have the value of a is minus 6. So it is going to be minus 6 whole square minus 4b is equal to 0. So it is going to be 36 minus 4b equal to 0. So b will be equal to minus 36 by minus 4, and it's going to be ultimately 9. So we have found the value of b as 9. Very simple sum. We have just used the first equation and one of the roots. So we found out the other root. We find the value of that other root as 2. We put the value in the previous equation to find the value of a, because in this equation we had two unknowns, a and b, and we had to find b. So there had to be some way we had to find the value of a. So we used this information to find the value of a, and we put this value of a in this case in the discriminant to find the value of b. So very simple equation. Hope you understood. Now let's move on to the next one. So here we are into our next question, which is question number 12, and let's see what is the question. It says that if the difference of the roots of x square plus px plus q is equal to 0 is 1, so difference is 1, then show that p square plus 4q square is equal to 1 plus 2q whole square. So it is not that tough. So let's move on to the solution. What we have here, what is given is the difference of the roots of this is 1. So if we take one root as alpha, then the other root is going to be 1 more or 1 less than that. So either it is going to be alpha plus 1 or alpha minus 1. So whatever we take, we can use that as our base. So let one root of x square plus px plus q equal to 0 be alpha. So if one root is alpha, therefore other root will be alpha plus 1 or minus 1. So let me take alpha plus 1 because it does not make much of a difference. So alpha plus 1 and alpha. So these are going to be the two roots, and that because the difference of this and this is going to be 1. Okay. So now we have the two roots of this equation. So what we can find from here is the sum of the roots and the product of the roots. So now sum of roots is equal to always minus b by a. So in this equation it is going to be minus p by 1. So what is sum? We have the two roots as alpha and alpha plus 1. So it is going to be alpha plus 1 is equal to minus p. We are going to have twice alpha plus 1 equal to minus p. So now again we can have the product of the roots. So product is going to be product of roots is going to be minus c by a. So here it will be going to be q by 1. So what is the product? Product is going to be alpha into alpha plus 1. So it is going to be alpha into alpha plus 1 equal to q by 1, or let me write it q. So here, since I have to use alpha, let's find the value of alpha from here. So what I am going to get from here is twice alpha is equal to p minus 1, and alpha is going to be p minus 1 by 2. So I can use this value here now. Okay. So let's see what to do. This is alpha into alpha. So it is going to be alpha square plus alpha equal to q. So let's put this value in place of alpha. So it is p minus 1 by 2 whole square plus p minus 1 by 2 is equal to q. Alright. Now let's go on solving this. So if I break the value, break the formula, it is going to be p square minus twice p plus 1 by 4 plus p minus 1 by 2 equal to q. So let's move on. Let me rub this place so that I can do the sum. I'm rubbing the left hand side. Taken the value already. So let's continue with this one. In the next line we are going to take the LCM. So the LCM is going to be 4. We are going to have p square minus twice p plus 1 plus 2 into this, because the LCM is 4, it is going to be twice p minus 2 equal to q. So let's side change this one and see what happens at the top. This 2p and minus 2p plus 2p will cancel. So it will become p square, and 1 minus 2 is minus 1. P square minus 1 is going to be 4q. So let's change the side of this. So it is going to p square is equal to 4q plus 1. So let me write what we have to prove here, so that we can keep track of where we are going. So from the question I can see that what we have to prove is p square plus 4q square is equal to twice q plus 1 whole square. I guess I am right. Yes. Or the question is actually that does not make much of a difference, but still let's follow the book. So this is what we have to prove. So what we have here is 1p square equal to 4q plus 1. So now here we have to do something extra. And what extra is it? We have to add one 4q square, because this 4q square from here it is missing. If I bring in the 4q square, then it is going to make a huge difference. Let's see how. Here we have the p square. Let me introduce 4q square here. So if I add 4q square on the left hand side, I have to do the same on the right hand side. So that's what I am going to do. 4q square I have added plus the remaining part, 4q plus 1. Now it is going to be changing. So p square plus 4q square, that is what we have. In the left hand side, we have got the left hand side all right. Let's see what happens to the right hand side. 4q square we can write as twice q whole square. This part we can write as 2 into twice q into 1. Plus we can write 1 square. It does match with the formula of twice q plus 1 whole square. So that means we can write p square plus 4q square is equal to 1 plus 2q whole square, and that's our proof. I hope you understood this. First you have to find the sum of the roots, from that find out the value of alpha, and then you move to the product of the roots, and just by solving it or simplifying this one, you can find the required proof. Only one thing you have to do, and that is adding this 4q square on both sides. Just adding the 4q square on both sides, you can find how to solve this. Now if you want to know that how can I remember what to add, just look at the step before this. Here we have 4q square, p square is equal to 4q plus 1. From nowhere I can get a 4q square. So I need one 4q square which is there on the LHS. So you look at the LHS and you see that there is one 4q square, and just apply a little bit of common sense that if I add 4q square here, I can get something out of it. So here I have added 4q square to get the left hand side right. Once I got the left hand side right, it automatically manages the right hand side. Let's move on to the last question of today. This is question number 13. So here we are into the last question of today's lecture, and it is question number 13. So look at the question. It says that if ax square plus bx plus c equal to 0 and bx square plus cx plus a equal to 0 have a common root, then we have to prove a plus b plus c equal to 0 or a equal to b equal to c. This is a little bit lengthy sum but a very easy sum. Let's see how to solve this. So we have these two equations and they have a common root. So let us take the common root as alpha. So let alpha be the common root. Therefore, if I put alpha in place of x in both the equations, what am I going to get? Therefore, the equations are going to be a alpha square plus b alpha plus c equal to 0. And the second equation is going to be b alpha square plus c alpha plus a equal to 0. Okay, so now let's do cross multiplication. So by cross multiplication, what we are going to have, let's see what we get. We are going to have alpha square, then we are going to have alpha, and we are going to have 1. So let's see what we put here. I hope all of you are very aware of the cross multiplication method, and let's try and put it to action. So for alpha square, we are going to have b into a and c into c. For alpha, we are going to have b into c and a into a. And for 1, we are going to have a into c and b into b. So a, c, b, b. What we get at the end is alpha square, b minus c square. Here we are going to have alpha, bc minus a square, and we are going to have 1, ac minus b square. So this is what we get. Now let's get solving this one and see what we can get from here. So let me rub the top part so that we can go on solving. Solving this part will help us get to the answer, so you don't have to worry much. So let's take this back. So what we are going to do now, I am going to equate this one with 1 and I am going to equate alpha with 1. So in two parts we are going to do. So now first I will be equating alpha square, that is alpha square by ab minus c square is equal to 1 by c minus b square. This is one, and the other one is going to be alpha by bc minus a square equal to 1 by ac minus b square. So from here I can find out alpha very easily. So let's find out alpha. Alpha is going to be bc minus a square by ac minus b square. So let's take it as number 1, and here I am going to put the value of alpha here. Okay, so let's do that. Here alpha square means, okay, let's do one thing. Let's change the side of this so that we get only alpha. So alpha square is going to be, this is going to change its side. So it is going to be ab minus c square by ac minus b square. It will be easier for us to do this way. So value of alpha is bc minus a square and ac minus b square. What we get from here is bc minus a square whole square by ac minus b square whole square is equal to ab minus c square and ac minus b square. So here we have ac minus b square whole square and ac minus b square. So let's cancel this one with the square. Okay, so what we are left with is, let's write the formula of this, and we can say change the side of this one to the right hand side. So what is going to be the formula? B square c square minus twice a square bc plus a to the power 4. And on the right hand side we are going to have ac minus b square into ab minus c square. So let's simplify this further and see where we get to. So this one, let me keep it this way, b square c square minus twice a square bc plus a to the power 4. And here we can get this into this, so it is going to be again a square bc, then minus ac cube. Then we are going to have this one where it is going to be a b cube, and at the end we are going to have minus minus plus b square c square. So now we will do side change. We will bring everything towards the left hand side. But before that, let's see if we can cancel something. See, b square c square, b square c square. So we can cancel it right here. We don't have to change sides. Okay, now let's change the sides. Let me write this one at first. It is going to be a to the power 4. Then we are going to minus 2 a square bc. So now the side change will be minus a square bc. It is going to be plus ac cube. It is going to be plus a b cube equal to 0. Okay. So now let's go back to our next step. Let me erase this part. In the next step, what we are going to have is, if I look close, I can write this as a to the power 4. This 2 will give me minus thrice a square bc. Here I can have plus AC cube plus AB cube equal to 0. So if you see, in all the terms we have one A. At least A is common in all the terms. So let's take A as common. What I left with here is A cube. From this one I am left with these two, see C cube and B cube. So let me write B cube here and C cube here. So these two are done. And from this one I have minus 3, one A is gone. So I will be left with ABC. I hope that's clear. I have taken the A as common and rearranged what is inside. From here I get A cube, from here I get only C cube, and from here I get B cube. From this one I get 3 ABC because one of the A has gone outside. So now I will side change A, so A will be gone, and this formula I know, A cube plus B cube plus C cube minus 3 ABC, this formula is known to us. So let's write that formula. A will be gone, so for this we are going to have A plus B plus C into A square plus B square plus C square minus AB minus BC minus CA equal to 0. So let me erase this part. Easier for me to do the sum. Okay, so this is, let me keep it this way, A plus B plus C. And here, let me do one thing, let me bring in 1/2. If I bring in 1/2, then I have to multiply the whole thing by 2 so that the value remains the same. So if I multiply everything by 2, I am going to have A square plus B square plus C square minus AB minus BC minus CA equal to 0. It is going to be A plus B plus C into half into twice A square plus twice B square plus twice C square minus twice AB minus twice BC minus twice CA equal to 0. Let me bring the half to the front, half into A plus B plus C, and see what I can do in the inside. Since we have 2A square, 2B square and 2C square, we can split it up into A square plus A square, B square plus B square and C square plus C square. Using that, I will rearrange. So see how I rearrange the things. From here I will take one A square, from here I will take the minus twice AB, and from here I will take one B square. So what do I get? A square minus twice AB plus B square means A minus B whole square. Similarly, what I can do is I can do B square minus twice BC plus C square, and I can do C square minus twice AC plus A square equal to 0. So now you can see I have got one A minus B formula, B minus C formula and C minus A formula using these. So now let me change the side of half, it will be gone. So I will be left with A plus B plus C. In the inside I will be left with A minus B whole square plus B minus C whole square plus C minus A whole square equal to 0. Now here we have come to the ultimate position where we have two things multiplying to get 0. That means either this will be 0 or this will be 0. So what I can write from here is, I can get either A plus B plus C equal to 0, which is one of our proofs by the way, or let me write it here, or I can have A minus B whole square plus B minus C whole square plus C minus C A whole square equal to 0. Now the thing is, no square value can ever be negative. So since all these three are squares, this will either be 0 or this will be positive. So for this, and if these are positive, then we can never have the sum of three positive numbers as 0. That means we must have all the three of these as 0. So it should be 0 plus 0 plus 0 equal to 0. So that means therefore A minus B whole square will be equal to 0, which implies A minus B will be equal to 0. That means A should be equal to B. Also B minus C whole square will be equal to 0, which means B will be equal to C, and C minus A whole square will be equal to 0, which means C equal to A. So from these three we can have, therefore, since A equal to B, B equal to C and C equal to A, therefore A equal to B equal to C. So these are the two proofs, A plus B plus C equal to 0 and A equal to B equal to C. So that is all we have about today's video. I hope you understood this. It was a very lengthy sum, but a very simple sum because nothing exaggerated or nothing extravagant we have to do in this sum. Only maintaining simple steps and just doing one thing extra is bringing in half and 2 here so that we can get the formula of A minus B whole square. So hope you understood what I explained today in the video and hope you liked the video. If you liked the video, then do make sure you give it a like at the bottom and also share in your comment section how you found this video, whether it was helpful for you or not. And if you think I should do any of the sums which I skipped here, then I'll be loving to make the video for you. And as you can see, I'm sweating it out here. So if you want to support my channel, then make sure you click the subscribe button and the bell icon as well. I would love that. I really appreciate that. So if you want to support me, if you want to support the channel and allow me to make more videos for you, then kindly do show your support by subscribing, liking and commenting. Thank you everyone, and until next time, cheers.